Uh, classified paper, classified paper 4, uh, which is related to block 1, work energy and power. Figure 2.1 shows a forklift truck lifting a box. The electric motor that drives the lifting mechanism is powered by batteries. State the form of energy stored in the batteries. Which form of energy is stored in the batteries?
Chemicals.
So chemical. You can use mic, chat, or screen annotation to answer these questions. Okay. The next is the lifting mechanism raises a box. So the lifting mechanism raises a box of a mass 32 kg through a vertical distance of 2.5 in 5.4 seconds. Calculate the gravitational potential energy gained by the box. Whenever you're solving a question in physics, 1 mark is for writing a formula or showing a substitution. So the gravitational potential energy, or GPE, equals mgh, mass into gravity into height. So the mass of this object is 32. The gravity will take as 9.8 and the height is 2.5. What's the gravitational potential energy? 70? 784 joules. That's the gravitational.
Then 800 joules also correct.
Yeah, you rounded off to 800.
It's rounded.
Rounded off is 800, but you write 784. The marking scheme answer is a rounded off answer.
If we write the rounded off answer.
It's fine. This is correct. 784. So 784 joules is the energy. Next is efficiency of the lifting mechanism is 0.65 or 65%. Okay. Calculate the input power. So how we calculate the formula? First, you write a formula that efficiency is a useful power divided by input power into 100. Efficiency is given to us, which is 65. What about the useful power? We know the useful energy because when the lifting a forklift, it lift an object, how much energy was there? 784. 784 joules was there. 784 joules of energy was there. But the efficiency is a useful power divided by total power input multiplied by 100. So what we can do, first we can work out the useful power. What is the useful power? The useful energy is 784. How to get the power? Because it's taking 5.4 seconds. The answer is not 78.4. The answer was 784 because 32 times 2.5 times 9.8 cannot give 78. So first we need the useful, this is the useful power output. So this is the energy, 784 joule is the energy. How to get the power? So the power is energy divided by time. So the useful, this is a useful because it's lifting, so it's a useful, like output. So the output energy is 784. And what was the time interval? How much time it was taking? 2.5. Sorry, 5.4 seconds. So it was taking 5.4 seconds. So what is the useful power? 784 divided by 100 and 145.1 or 145 watt, I can say. Okay. Now, so this is a useful power output. How much energy is used every second? That is called a power, 145 watts. We'll use this formula. Efficiency is a useful power divided by total input power into 100. So the efficiency is 65. The useful power is 145. Input power is unknown and multiplied by 100. You simplify for x. X is the input power. So x will multiply there. So x is equals to 145 multiplied by 100 divided by 65. What's the answer?
So the 784 joule was the energy.
784 was the energy, but because the question is about power, that's why we first get the power.
223.1 is the answer.
223.1. So 220, and the unit will be watts. Okay. So if you solve by using this 784, you will get the useful. There's also another way to do the same question. What you can do is first you find a useful input energy, like the total input energy. You use a formula that efficiency is a useful energy output divided by total energy input into 100. So efficiency is 65, useful energy output was 784, input energy we don't know. First we find the input energy. So it will be 784 multiplied by 100 divided by 65. What's the answer for input energy? 784 times 100 divided by 65. Energy, I'm asking. You can solve first.
1206.
1000?
No, 1206.
So 1206 joules of energy is there. Now you need the power. You can solve the question by two ways. First, you find the input energy, and the input energy divided by time will give you the power. That is one method. Or first, you find the useful. First, you find the useful power and then use the efficiency formula and work out the input power. So both ways it is correct. So now if we need the power, it is energy divided by time. So 1206 divided by 5.4. What's the answer? 1206 divided by 5.4. What will the answer? Same answer, 223. So you can do this question both ways. First, find the useful output energy, like useful power, and use a formula for efficiency, or you first find the total input energy and then divide it by time, you get the final power. The next is, what is that? Means high voltage supplies are there, which is supplying you electricity, high tension wires. The batteries are recharged from a main voltage supply, like we have a main voltage supply and the batteries are recharged. That is generated in an oil-fired power station. Like it is electricity is generated by burning the fossil fuel. By comparison with a wind farm or a windmill, state one advantage and one disadvantage of running a power station using an oil. What is the advantage?
A high efficiency.
Energy. High energy
High
density.
efficiency, high energy density. What else?
It's not polluting the environment.
No, comparison. Comparison of a wind farm, we need advantage of burning oil.
Takes less space
It's faster.
Less space, yes.
Not dependent on weather.
and
It's
less building
reliable or
cost.
does not depends on weather. Some of the students are using the marking scheme as well.
So what can be disadvantage?
What?
Disadvantage.
Disadvantage. What is the disadvantage? Pollution, like,
Polluting.
yeah, pollutant,
Pollution
produce
and it is
pollution,
non-renewable.
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 What else?
Not renewable.
Greenhouse gas effect.
Yes, Hamid.
The greenhouse gas effect disadvantage.
Sorry, I don't get what you said.
The greenhouse gas effect for disadvantage.
Yeah, produce
That's
greenhouse or
polluting.
toxic gases, greenhouse gases. That's a disadvantage. Okay, topic 1.8, which is about the pressure. A rectangular container has a base with the dimensions of 0.12 and 0.16 This is a dimension of the base, the length and the width of the base. The container is filled with a liquid and the mass of the liquid in the container is 4.8. What is the weight of the liquid?
The 48.
47.04 Newton.
So weight is mass times the gravity, so 4.8 multiplied by 9.8.
9.8.
47 Newton.
So 47 newtons. When you write, don't solve the, like here you have to just write the final answer. Solution you will do, like example, you need weight, it will be mass times the gravity, or you show a substitution here, but write the final answer in this. Don't write the solution on these lines, okay? G. Weight is mass times the gravity. The next, we need a pressure. How we can work out the pressure? Because we have a rectangular, the container is there, which is having a rectangular base. Pressure due to the liquid on the base of a container. So how to find the pressure of the liquid? So pressure exerted by the liquid depends on the density, depends on the gravity, and depends on depth. What is the density here? We don't know. What is the gravity? We know, and the depth also is not. So it means we cannot use this formula. Then what else we can use? What else we can use? We can use a formula that pressure is force over area as well. What about the force? The force is a weight. Like how much, what is the weight of the liquid in this example? 47.
47
So 47 Newton is the force. And what about the area, the base area? It's given 0.12 and 0.16, the length and the width. So it will be 47, the force, divided by the base area, which is 0.12 times 0.16. So when you simplify, 47 divided by 0.12, we can also, yeah,
2,447.
3,447.
47.91.
3,447 Newton per meter square. Yes.
Sir, I'm getting 2,447.
2,447. What about others?
Sir, I'm getting 2450.
So it means
Sir,
2,000.
2,447.
Okay, 2,447. You can write Newton per meter square or you can write Pascal. Look, usually when we want a pressure of the liquid, we use this formula, but the other formula is also valid. If we know the weight of the liquid in a container and we know the base area of the container, we can also use this formula. It will give the same result. Like if we were having a density of a liquid and the depth of the liquid, both when we use this formula, we'll get the same result. It will not make difference. Explain why the total pressure on the base is greater than the calculated value. Like example, we calculated that it was 2,447 Pascal or Newton per meter square. But in practical, the pressure will be higher than this value. What is the reason? What could be the reason? No. The question is, look, there's a liquid inside a rectangular container, and this liquid is applying a pressure which is 2,447 Pascal. We calculated. The question is, explain why the total pressure on the base is greater than the value we calculated. Because what we did, we only calculated the pressure of the liquid. We only calculated the pressure of the liquid, but in reality, what will happen? There will be atmospheric pressure as well. Liquid is applying a pressure.
Why you can say?
Because of the gravity is having weight, and because of the weight, it exerts a pressure. So you cannot mention gravity. There is air on the top of this liquid. That air is also exerting a pressure. That's why the total pressure will be higher than what we calculated. We just calculated we just calculated this pressure. But because there are air particles above the liquid surface and these air particles are also exerting a pressure. So the total pressure on the base, what will the total pressure on the base? It will be the sum of the liquid plus the atmosphere. Is it clear?
They change it to the- No worry, that-
So the main reason is the atmospheric pressure, the pressure of the atmosphere. The depth of the liquid in a container is 0.32. Calculate the density. So pressure exerted by the liquid is density, gravity, and depth. What was the pressure exerted? 2,447. The density of the liquid is unknown. The gravity is 9.8 and the depth is 0.32. If we need the depth, so 2,447 divided by 9.8 times 0.32. What is the density? What is the density? 785 kilogram per meter cube. This is one way. This is one
Sir,
way
I
of
got
finding
780.
780. Okay.
Yes,
Yes,
sir. I
sir.
also got 780.
780 kilogram per meter cube. This is one way of finding the density. There's also another way. You have the mass and you can also have the volume of the liquid in the container. The mass of the liquid is 4.8. And what about the volume? It will be length, width, the base area times the height, which is 0.32. So if we need the density, it can be mass divided by volume. So mass is 4.8 and the volume will be 0.12 times 0.16 times 0.32. When you divide, again, you will get 780 kilogram per meter cube. So either use this formula, density is mass over volume, the total volume of the liquid inside and the total mass of the liquid. So mass over volume, you get the density. Or you use a pressure, that pressure is density, gravity, and depth. You can use the first formula that the pressure is density of a liquid, gravity, and depth. Or you can also use that the density is mass divided by volume. Page number 45. Part C. And about part B, the question is, when we calculated the pressure of the liquid, we got 2,447 Pascal. That's the pressure we got. But they're saying in reality, the pressure will be higher than the calculated value. Why? Because above the liquid, there will be air particles. These air particles will also push, and we call that as an atmospheric pressure. So the pressure of the atmosphere is also contributing to the pressure on the base. So the total pressure will be equals to the pressure of the liquid plus the pressure of atmosphere. So we just calculated a liquid pressure, but because atmosphere is also exerting a pressure, that's why the total pressure will be higher than the calculated value. That was a B. Page 46. A rocket is stationary on the launch pad at time t is equals to 0. The rocket engines are switched on and exhaust gases are ejected from a nozzle of the engine. The rocket accelerates upward. Figure 1.1 shows the acceleration of a rocket. This is the acceleration time graph. You can see first the acceleration is increasing and then the acceleration is constant. If I want to make a speed time graph for this is the acceleration. Like as you can see, the value of the acceleration is increasing first on y-axis and the acceleration is not changing. So if I want a speed time or a velocity time graph, how I draw acceleration increasing?
Curve.
Curve.
Like this curve. Yes.
And gradient will increase. And then how I'll
Yes.
show
I did like this and you didn't say good, sir.
good.
Sir, constant straight line. Straight line.
And then it will be a constant
Increase.
straight line. Constant, like why? Because acceleration is constant, so we have to draw a straight line. A speed time graph the constant expression is by straight lines. Speed time graph, increasing expression is by curve with increasing gradient. So we just have to join these 2 points. That will be the shape of the graph. Now define acceleration. How we define the term acceleration? It is
Change of speed in
but
unit
only,
time.
yeah, good. If you only say change in speed, that is not the complete definition. You have to say, and the best is instead of using the term speed is acceptable, but the best is use the term velocity, because acceleration is a change in rate of change in velocity. Rate means time, like a unit time. Rate of change in the velocity.
So we can
Rate of change in velocity.
we can also draw the formula, right?
You can also write a formula here. Yes. So on a figure, sketch how the speed of the rocket varies between time 0 and TF. So first you can see acceleration was increasing and then the acceleration was constant. So this is what we did. First we drew the acceleration is increasing. So the curve gets steeper and then the acceleration will be constant. So it will be a straight line. Clear?
Yes.
Is it rate of change of acceleration is not giving any physical quantity. Rate of change in displacement is velocity and rate of change of velocity is acceleration. But rate of change of acceleration does not give any physical quantity. Then next is sometime later, the rocket is far from the Earth. The effect of the gravity on the motion of a rocket is insignificant. As a rocket accelerates, the momentum increases. State the principle of conservation of momentum. What is the principle of conservation of momentum?
When two objects collide, the initial momentum is equal to the momentum after collision.
The gravity and mass is decreasing up, sorry, because we're waiting for the Earth, so the gravity.
This is whenever the question is principle, it means you cannot write you in your own words. It should be standard statement. Like if they ask principle, law, definition, it should be proper words. You cannot write any statement or principle in your own words. So you have to say that in isolated system, the total momentum before is always equals to total momentum after. You have to learn this statement, the conservation of momentum. Isolated system, 1 mark, momentum before and after, another mark. So momentum before is equals to momentum after, but what is missing here in the isolated system? Isolated system means the system which is not influenced by any resistive forces. Explain how the principle of conservation of momentum applies to accelerating rocket and exhaust gases. Yes, how we apply, like example, we have an exhaust gas and the rocket is accelerating. How we apply the principle? Example, if this is representing a rocket, yes.
The exhaust gas exert force downwards, but the rocket goes up.
So first thing, when we say what is the total initial momentum, first, what is the initial momentum here? For a rocket and the exhaust gases, initial momentum, the total of 0. So if the initial total momentum is 0, the final should also be 0. So how the final is 0? When the exhaust gases are, example, moving downward or opposite direction, so the rocket will move upward and they will have the same momentum. So explain how the principle of conservation of momentum applies to accelerating rocket and the exhaust gases. So first thing we'll mention, the initial momentum is 0, so the final should also be 0. So the exhaust gases are moving in one direction, the rocket will move in opposite direction to conserve the momentum. If the momentum of the exhaust gas is example 30, the momentum of the rocket should also be 30. But because it's a vector quantity, so one will be positive, another one will be negative.
How will we write this?
You will mention first thing, the total momentum is conserved and the initial momentum is 0. So if the initial momentum is 0, the final momentum should also be Zero. And how a final momentum could be zero? So if the exhaust gases are moving in one direction, the rocket should move in opposite direction. That's how the rocket accelerated. Is it clear? The rocket propulsion? Anyone having a doubt or a question in this part C1 and 2?
So, sir, what would be the answer here? Can you tell again? Only the
Yes.
answer.
Look, for what you will mention, first thing you will mention, as the momentum is conserved, initial momentum is zero. In a rocket, if the initial momentum is zero, the final momentum should also be zero. So if the exhaust gases are moving in one direction, the rocket should move in opposite direction.
So, just open your voice recorder, please, right? It's like you were
Is it clear? Abdul Rahman?
Yes, sir.